Hello, hello. So last Monday I did yttrio's doubling loop, although I actually recorded that back in April or whenever that puzzle got published. So I don't remember it very well, but I had a request when I finally posted that to do their other puzzle, halving loop, or one of their many other puzzles, but a play on the doubling loop is the halving loop, where instead of doubling values on the loop, it's halving them. So we're going to try it and see how that goes. So rules here. Normal Sudoku rules apply. That means the digits 1 to 9 appear in every row, every column, and every marked 3 by 3 box. We have arrow rules. So the digits in a circle are going to equal the sum of the values on the attached arrow. And then finally, I'm going to draw hopefully a loop around the grid somehow that will have all the values, cut in half all the values for the purposes of arrows. So if we had something like this, what that would mean is this cell would equal, or half of this digit, whatever that is, equals these two plus half of these two middle ones. So if my loop, let me just draw it out. My loop did something like this. Let's make that gray. Then, and these were not loop, then what that would mean is, actually, I don't know if I'll be able to make this possible. Let's say that's 9. Yeah, I don't think that's going to work even maximum, that's not going to work, this is it's a useful thought experiment to think through how this box is going to work. So let's try somewhere else. Let's say this one. Let's say it's something like this. Let's say the loop did that. Then I may be able to put a 9 here, and a 1 here, and a 4 here. So what that would mean is, and suppose that's all not loop. Oops. Then what that would mean is this cell divided by 2, which is 4.5, is this cell divided by 2, which is a half, plus this cell, which is 4. So 4.5 is 4.5. So that arrow works by the halving loop like that. So that is how we're going to start. Clearly this box is going to have some problems because I've got an arrow with 4 digits on it. So the loop has to get in here. And an arrow with 3 digits on it. So there's definitely a lot of halving going on here. And I'm thinking that this can't be halved at all. Well, but only because they can't all be halved. Right? So if the whole, well, no. Yeah, no, this digit, that's okay. This digit, that can't be halved because this is a 4-cell arrow. If this were halved, even if everything else were halved, that would basically just make it a regular arrow. And that doesn't work with 4 cells because the smallest those 4 digits could be is 10, and I can't put 10 here. And if there's anything that isn't halved, that is even worse. So this has to be off the loop, which means this can't be on the loop because if it is, what would happen is the loop would have to go through the corner and then it would have to bend down and touch itself. So that doesn't work, which means this is also not on the loop. And then one of these has to be on the loop. So this has to be, oh no, could do this. I have to be a little careful here not to get ahead of myself. Because in my head I was thinking, well, the loop's definitely going to go through those 2 circles. But I don't know if I can definitely prove that's true. So let me just think about it for a second. So, like, let's suppose that it didn't. Or so I'm trying to. Is it possible for this to be unlooped? What that would mean is that the loop would have to touch this because I can't have this all be unlooped because that would sum to at least 10 and that can be at most 9. So the loop would have to do something like this. And the loop could go left, but it couldn't go back up. So that's kind of the best I could do on this arrow to make these as small as possible. And then if I do this, I actually do have some wiggle room here in this arrow. But I don't have a lot of wiggle room in this arrow. So okay, maybe I should think about this coupling more holistically before thinking about how the loop can go. So let's think about these. let's suppose that all 5 of these, which it's not possible. So in fact, it's not possible. So let's say that, does it have to be the case, and I think it will have to be the case, does it have to be the case that 4 of these, I don't know which 4, but the 4 is the most I could do, because if I do all 5, the loop will have to bend in on itself and touch itself, which won't work. So, but 4 works, at least those 2 ways. So does it have to be 4? So let's suppose, I'm just going to color these for the sake of remembering that I'm doing 4. I don't know how this would go, if this is true. But if I had 4 cells halved here, then kind of the smallest I could make these 2 arrows combine is if I put the bigger numbers here and the smaller numbers here. So the bigger numbers get halved, not the smaller numbers. So this is a total 6 plus 22, 11 is 17, which means this would have to be unhalved. Okay, so even at the smallest possible I could make these arrows, this would have to be unhalved and therefore be off the loop. So this cell is definitely off loop. And since at least one of these has to be on the loop, let me put it this way. If this cell's on the loop, then the loop has to go through that little gap and goes like this. If this isn't on the loop, then this has to be on the loop by this arrow logic. So we have that. Now the problem is this cell, if it's on the loop, can't go in and out inside this gap. So actually this does have to get out like that. So we do get looping like this. I guess I didn't definitively show that we need 4 on the loop here. So what did I show? I showed that if there are 4 on the loop, which is maximal, 4 arrow cells on the loop, then this is still unhalved. But I didn't show, I mean, I kind of did, but not literally. Like what's wrong with, say, this and having these be unlooped? So what's wrong with that is I get at least 10 here. This could be 9 more. That's 19. I can't do 19 here. That doesn't work. So the loop has to get to here. And now the problem is I don't know whether I go down this way or down this way. But either way, this doesn't go back here. So this is looped. Whoops. And this is where I actually have a big problem with the way loop rules are written. I know it's just convention, but like it says that this is not a comment on yttrio and the rule writing ability. This is how these are always written. But it says the loop can't touch itself even diagonally. But like anytime a line turns, it touches itself diagonally, in my opinion. So I mean, the way you really should think about this is, and the reason I bring this up is, I want to do something like, well, now this can't be on the loop because of like this cell, but that's not true because this could turn, and even though it touches itself diagonally, that's fine because it's at a turn. So what it really should say is something like, digits that are more than 2 apart on the loop cannot touch even diagonally, something like that. But that's my own little rant. So one of these is loop, one of these isn't. I don't know which. And I think what that means is that these are from 1, 2, 3, and these are from 4, 5, 6, 7. This is an 8, 9 pair, right? So I did that all maximally before, or like, minimizing these as much as possible, force these to be maximized as much as possible. So my halving cells are going to be 4, 5, 6, 7. Oh, and what that means is these are going to be the same parity. So because this is an integer, and those are integers, this sum is an integer. So it's either 10 or 12. If it's 10, that's 5, which means this could total 1, 2 or 1, 3. So there's definitely a 1 on here. It can't be 2, 3, that'd be 5. Even if this were 9, this could only sum to 8, which it's too big for. So the 1 is here. One of these is the 2 or 3 that's missing here, and the other one is this. I think that's the best we're going to get here for now. But that one is really useful for this arrow because this, well, I guess it's not the 1. It's the 1 with 2 or 3. Because this arrow here, let's say none of this were loop, right? Then what that would mean is this would need 2 digits from 1, 2, and 3. Because if I didn't, the lowest I can make it is 1, 4, 5. and that sums to 10, which doesn't work. So at least something here is looped to have it. And there's no way this is looped. Because if this is looped, the best I can do is looping all this, and that breaks for the same reason before. So this is unlooped, and I need loop in here. So for the loop to get in and out of this corner, it's got to go like this. And that's got to go down, and it can't go back to itself, so it has to go down again. These can't be loop. Oh, that's interesting. So almost all this is going to have to be loop. I hope I didn't make a mistake. That seems really unlikely. But this digit can repeat, actually, so it's not that bad. How is this going to work? I think it's going to have to be the... Is there any way I can do this with only... Well, what's the smallest I can make this? 1, 1, 2, 3. That's 7, which definitely doesn't work if nothing's halved. So if it's 1, 1, 2, 3, and the 2, 3 are halved... Let's say just the 3 is halved, which doesn't make any... Well, it could make sense with this. So let's say just the 3 is halved. Then 1, 1, 2 is 4, plus 3 is 1.5, and that doesn't work either. I need 2 things looped here. I can't have these 2 looped because that's going to break. So this is going to be on the loop, and then one of these 2, but I don't know which one. So this is a... maybe I should start using, like, not yellow. Let's start using pink as like one of those 2 are looped and one is not. These can't be looped because this can't go in and out. So these are green. If this is looped, I could still do this, I think. That still works. Is there any... No, this could actually be quite small. Because this could be 2, 4, 5. Well, it can't be 2, 4, 5. It could be 2, 4, 6, I guess. Which is 12. This could be 6. But, I mean, 6 is pretty big. So it's 6 or bigger. And then what about this one? So one of these is halved. If we do, let's see, 1, maybe it can't be this. Let's say I go this way. This is at least 1, 2, 3, 1, which is 2, and 4 is 6. That doesn't work. If we do 1, 1, 2, 4, that'd be 3, 4, 5. Oh, this doesn't have to be odd because this is halved. This could be, oh, so I think it has to go this way. So the best I could do is to have 1, 1 unhalved, 2, 3 halved. That would be 2.5 and 2 is 4. Wow, that worked. It has to go exactly that way. That is very restricted. So these are both 1. This is a 2, 3 pair in some order. That's 8. That's 9. Let me just... Yeah, I'll turn off my pencil checkers. Make it harder for me to do Sudoku. Now I have 1, 2, 3 here, so this can't be green because green had to be 1, 2, 3. So the loop goes this way. This is 2 or 3. Yeah, so I think, the way this works, I think it works out this way. If this is 10, so this is 4, 6, this becomes 1, 3, this is 2 and 5, 7, and that all works out. Whereas if this is 5, 7, that's 2 and the 4. So the 4, 6, because I have the 1 here. Yeah, because I have the 1 here, everything else is just offsetting. So it's either 5, 7, 2, or 4, 6, 3 in these situations. These are also 4, 5. I'm going to write that in because that's actually pretty restricted on this arrow. And I'm starting, because there's no 1 here. So, okay, here's a better thing. One way to think about this, instead of thinking about this as a halving loop, I'm going to think of the cells that are not on it as being doubled. And that's going to be exactly equivalent for the purposes of arrows. We're thinking of this arrow restriction as this plus this equals half of these plus this is the same as saying double this equals this plus double this. It's exactly the same. I'm doubling everything. Doesn't change the equality. And then I think it's going to help me, it's just going to help me do some math because I can work better in numbers 1 to 20 than half integers 0 to 10. So but what I'm seeing is if this is doubled, let's say even, I mean, it certainly isn't going to be the case that we do this, right? This is all to say, can this connect to here? I think what's going to happen is this is going to go down and this is going to go down. Actually, this is green. I know that. And this can't touch itself, so that's green, even diagonally. So can this touch itself? Or put it another way, can this be halved? If this is halved, it's at most, we'll do it that other way. If this is at most 3.5. And even if this is halved, 2 plus, oh, well, this can't be 2, 3 because of this. It actually does almost work, except for this cell. So this can't be a 2, 3 cell because of this. That would break this cell. So if this were 7 halved, 2, 3 halved, that just barely works, but that breaks this. So we can't have this cell halved, which means this cell can't be on the loop. The loop has to get out here. The loop has to go down here. And now, because of this can't be 4 or 5. Because this is 2, 4, 2, 5, or 3. It can't be 2, 3, because that's this. It's going to be bigger than that. So that's 6 or 7. This is the other, whatever, so this cell, whatever that is going to show up here with either 4 or 5. That means 9 is going to go here. Oops. Okay, what's the smallest this can be? Because now I have some cells. The smallest this can be is 2, 4, 5. Oh, I already did that. 12. Yeah. Okay. Oh, but 2, 4, 5 now breaks this. Oh, but 2, 4, 6 doesn't. Oh, but 2, 4, 6 has a 6 on it. Which does break all this. So, yeah, so if this is 6, the only way that works is if this is 2, 4, 6, which is not going to happen. So that's there. Can I put a 7 or 8 in here? I probably can. Does 2, 4, 8... So 2, 4, 8 is 14. Would be 7 doubled. Yeah, that does work. This would be 1, 3, 5, 6. Yeah, that's starting to look pretty good, actually. But I do know these add up to these add up to either 14 or 16, because that's this doubled. I don't know. Let's think about, is there any way this is halved? No, this can't be halved because this is too long. Even if this is all halved, which it couldn't because of the loop, but even if this were all halved, this would be too big for this. So that's off loop. So this has to keep going down. This can't be loop because it would bend and touch itself. This can't be loop, same reason. So this has to continue on. Oops. Hold on. Accidentally changing my colors here. That's on the loop, that's on the loop. But now this could bend around, and this could bend backward. At least something here is looped, but this could just do this, and we might be fine. If these are not halved, this would have to be 6 or 8, and this would be 1 with 2 or 3. But I could have even both of these. I mean, this could, I guess it can't go all the way down to here. This could do this and be fine. The reason it can't go all the way down to here is then I'd have this dangling loop over here that needs to get out and can't touch itself. But it could go down to here. It could even do something like this. That'd be kind of nice if we end up with something like that. I don't know why I find that nice, but it's like kind of maximally filling this area. Okay. Well, can this be? I think this can't be. I think this can't be halved. Oh no, it could, because this could come down and do this. Yeah, never mind. I was thinking this couldn't connect here because then these would all be green, but that's foolish thinking. Okay, 8 is up in here in this box, so 8's over here. So actually 8 does not go in this. So if this is 14, how do we get to 14? We could do 7, 6, 3. We could, no, because this is 14, this is 7. So if we get to 14, it'd have to be 6, 5, 3. Was I trying to do 16 before? No, I can't remember. Yeah, 7, 6, 3 is 16. Okay. But either way works. If this is 7, we're trying to get to 14, I could do 6, 5, 3. So actually, that's forced. If this is 7, this is 6, 5, 3, because there's no 8. That would the only way to get to 14 with the digits left is 6, 5, 3. Which I mean, this is 1, 2. That's 4. That's 8. But that's fine. How does this work if this is 8 and 16? If we're trying to get to 16, we need the 7. Because otherwise the highest we can do is 6, 5, 4, which is only 15. So we need the 7. And then we need 9 more, which could be 6, 3 or 5, 4. Five, 4 would make this a 6. 6, 3 would make this a 4, 5 pair. Yeah, no, it's too many combinations. It's too many. I think either of those are possible. I don't see how that breaks yet. Well, this has to go down. Let's keep going with the easy stuff. This doesn't have a 1 on it, which is still possible if it's all unlooped. I could do 2, 3, 4, and 9, but it's only just barely possible. But I can't reject that yet. Yeah, no, I don't. This is all seeming fine. So what is the next step? I like how symmetrically we're kind of building down from both sides. It's kind of a nice feel to it. Is it this arrow? Because, so I have a lot of, where are my high digits in this column? Or maybe another way to think about this is how many digits do I need halved here? Can I do it with just 1? And I think the answer is no. I mean, this 9, 8, something like 1, 2, 3, 7. Yeah, that's too big. So the reason I went up to 7, I guess I could go up to 6. Oh yeah, 1, 2, 3, 6. Well, you know, if this has 1, 2, 3 in it, that breaks this. This needs either 2 or 3. Like this digit is here. So the smallest I could make the non-loop cells here, if there were 3 of them, would be 1, 3, 4. And this would be 2, 5, 7. So 1, 3, 4 is already 8. There's no way a half 6. So I need at least 2 loop cells here. Can I do it with 2? If I have 2 looped cells, I could do 1, 2 as unlooped. And it's the same digits, there's just more looped ones, right? So 1, 2 would be unlooped. 3 would have to be up here, with 4 actually, which I didn't think about before, but I didn't need to. This could be, well, another way to think of that is if this is 6, we get 8 of these digits, a total of 8 end up on the loop. If this is 7, a total of 7 end up on the loop. But with, it's hard to think through with the halving possibilities, whether, because the high digit, if I have 2 cells halved here, the higher of those 2 digits will get halved. So the best I can do is, I think, to make this 7, this 3, 4, and put 2, 5 down here, because 2 with a half 5 is smaller than 3 with a half 4. So we have 1, 2 down here, 3, 4 up here with half 5 and 6. So 3 plus half of 11 is 8.5. It's low enough, but the parities don't work out. But I wonder if I could just shift things around a little bit to make that work. So, but shifting around a little bit really breaks this a lot. Oh no, could I just do 8 instead of 7? So if it's 1, 2, this is 3, 4. Well, this is 7 though. Oh, yeah, 1, 2 over here, 6, 8. 6, 8 is, oh no, that's too big. Wait, what did I do before? 1, 2, off the loop. 3, 4 up here. 5, 6. Yeah, no, that doesn't, I don't think that can work. I think I need 3 on this loop. I think I need, on this arrow, I mean. I think I need 3 loop cells on the arrow. How would I do this with only 2 loop cells? 1 would be unlooped. I still really care. There's so many fiddly things you could change. What if I had, so this would be 9, this would be 8, maybe. What if I made this 6, 2, 4, and then I had 3, 5, 7. So I have 1, 3 off loop. That's already 4. I only have 5 left to play with, and I have 5, 7 left here. That doesn't work either. So this is complicated. Let's try thinking about it with doubles instead. So if this cell is doubled, can I do it with only 1 doubled cell on the arrow? So this could be 18. The doubled cell, no, it's with 2. We already showed that can be done with 1 or with 3 half cells. Wait, did we show that? No, I'm getting lost. No, we showed that it can't be done with 1 half cell. I want to show that it can't be done with 2 half cells, because if it's 3 half cells, that fills in all those, and I'll say why if this works. But I think that's right. I think we need 3 cells halved here. But it's so hard to show. Because there's so many kind of combinations. I wonder if there's an intermediate step here that makes this easier to see. I think we could show it. But I don't see where else to look. So why do these, how do I explain what I'm seeing here? The most I could make this is 9. Right? And then what can I put down here? So let's say I had these cells. It doesn't matter which 2. Let's say those 2 cells are halved and these are not. The best I could do, I would definitely put a 1 down here, right? Now, I put a 2 or a 3, I don't know which. And then the other one of these 4 or 5, I'd also put in there. And then probably let's just make this 6 or 7 and make that 8. Right? So what's the best I can do? Well, the smallest I could make this in total is 4, 6, which is 5, 1, 2, which is 3, which is 8. But the problem is I can't actually do that specific ordering. Because if I do 1, 2, that makes this 3, 4, 7. So let's just start there. If this is 1, 2, this is definitely 3, 4, 7, which makes this 5 with either 6 or 8. Which doesn't work because it's odd. So that just straight up doesn't. So this can't be 1, 2 actually immediately. Because if this is 1, 2, 3 is up here with 4. So the digits I have left are 5, 6, 7, 8. Oh, but that's not quite true. So I have 5, 6, 7, 8. 5, 7 is the best I could do. Oh no, that's 7. So I have 5, 6, and 8 to play with. So this has to be 6, 8. But that just doesn't work because, I mean, this is already 14, which is 7. It just doesn't work. So I can't do 1, 2. What I could do maybe is 1, 3. So if this is 1, 3, then I do get a 2 here. And now I have a little more wiggle room to play with. So 2 is up here. And the digits I have left to play with are 1 from 4 or 5 and 1 from 6 or 7. Now the problem is, actually no, it's not a problem. That works out. Oh wow, this actually might work just like this. 4, 6, if this is 4, 6, and that's 2, 5, 7. Wow, no, that does barely work. Wow. 4 and 6 is 5. 4 and 6 is 10. Halved is 5. Plus 4 is 9. Wow, that works. I really thought it didn't work because I wasn't thinking about it correctly. Okay, so that's not it. Because that works. So what is the next step? Well, I don't think this can be halved. I don't think this can be halved. Yeah, I should have seen this before. If this is halved, even if I have everything, because, oh, no, that's not quite true. I could do 9, 1, 3, 5. No, because I need, yeah, no, that doesn't work. It's exactly analogous here. I don't know why I didn't see it. It's because I was focused on the 1 up here, because the 1 really does make this easier to see because you immediately get 2, 3, 4, one of which is here. But the same logic applies here, which is if this is a real arrow, meaning to say it's either all not loop or all loop, then these 3 cells need 2 digits from 1, 2, 3, but that breaks this, right? And then I showed it over here that way, even though I had the 1 to play with. But if there's only 1 digit from 1, 2, 3, the lowest I can make it is 1, 4, 5, which is 10, which doesn't work. So that doesn't work, which means if this cell's halved, even if these are all halved, it doesn't work. So this cell has to be not halved, which means this comes out here, which means, because this is 3, 1, 2, yeah, so one of these at least needs to be halved. Well, first of all, let me see easier. This can't connect to itself because I would connect this loop and I'd have 2 loops going around. So this has to go down. This can't touch itself even diagonally, so it goes down again. Now I could do this, and in fact I think I have to, right? Because we said this needs looping, and it's exactly the same as this. I took too long to see that. It's exactly the same as this. I need looping, therefore it all has to be looped because I can't go in and out in 2 cells. So that's all loop. These are not. That's loop. And now what? Now, does this get me anything, or does this get me anything? Because this one's actually a little more restricted. I mean, this one's more restricted because I have 2 low digits here. This one's more restricted by the looping. 1, 2, 3 is, so 2, 3 is 5. 1 doubled is 7. This could be as low as 7. Which means this could be as, oh, maybe this could be 4. If this is 4, 1, 2, no, 4, that's 4.5. That can't be 4. And in fact, it can't even be 3, because that would immediately do 1, 2 here, which would break this. Yeah, so the way I'm going to think about this arrow is, this is the sum of these 2 plus that doubled. Could this be 2? 4. If this is 2, that's 1 or 3. So this can't be 1, 3. So I'm thinking about, if this is 2, then these sum to, if that's 2, doubled, that's 4, which subtracted from the sum means this sum is 3, 4, or 5. It can't be a sum of 3 because 2's there. It can't be a sum of 4 because that's there. But it could be a sum of 5. So it could be 2, 1, 4, 9, 3. That's very specific. So if this is 2, that's very forcing. And the only reason I'm thinking about that is if I could make this a 1, I could put a 1 here. I guess that would be the end of it. So maybe don't spend too much time thinking about that. What's the biggest these could be? So if this is a 1, these could total at most 7. So these would go up to 6. Okay, I don't know. I don't see it. So then now let's think about this. This is doubled though. I mean, this could be, even if this is 5, I could do 1, 3, 6 here or something. I've got a lot of wiggle room. Does have to be at least 5, because if this sums to 8, that breaks this. So what did I get out of this? Maybe it's something to do with this. No, because I don't need digits here. This could very easily be a normal arrow. It doesn't even need to have a 1 on it. I could have 9, 2, 3, 4. Well, okay, here's an interesting thought. Maybe it's interesting. I can get at most one of these. I know at least 2 of these are shaded. I was hoping to try to show that 3 of them are shaded. But I couldn't do that. It works barely if there are 2, but there are at least 2 shaded. And I can get at most 1 shaded from kind of, like, I think about this loop is going to connect over here somehow, right? And this loop is going to connect over here somehow. And whenever this loop jogs to the right, oh, is that true? Yeah, so it's a little more complicated than I initially saw, but if this dot jogs to the right here, it's going to get 1. If this jogs to the right down here, it also has to connect up here immediately, so it goes by 1. If this jogs to the right here, well, I can't go down now because of this down here, so it's got to jog to the right again. So whenever this jogs down, I can't go all the way here. So whenever this jogs down, it's going to go immediately through. And in fact, I can't do it here because that would force these 2 to be unshaded and this to be unshaded, because this loop will be connected through here. So this either connects straight through here or down through here like this. Either way, this has to come up and grab something here. Now the question is, can this touch this cell? Because if it does, it has to immediately go up, which means the best I can do is something like this, in terms of the smallest I could make this sum here. So if this is shaded, I get at most 2 more shaded cells. Like this can't go all the way through, because that will break this arrow. So so if this goes over and we do that, this would be at least 2. I can do 1, 3, 2, 4, 8. Yeah, that works. No, that does work. Okay. Okay. All right. It works. So then what is the next thing? And I could even do, this could connect over. Actually, I could do this even. Yeah. Weird. Okay. So let's... is there any reason this... So if this goes over straight away, that does put a lot of pressure here, because this is at most 8, which means this would definitely have a 1 on it, with either 2 or 3. Maybe that's it. Maybe this has to connect over. Oh, sorry, maybe this can't connect over. And as soon as this doesn't connect over, we are forced to 2 shaded cells on this, which is very forcing, as we saw before. It forces us to be 1, 3, 4, 6. Oh no! I just thought about it again, and that breaks this. Hold on. Did I do something wrong before? Hold on. If we have something like this, let's just do it this way. If we have something like this, I said before this works if we had 9, 1, 3. Did I do that? That's 10. Yeah, that barely worked. But that doesn't work because, oh no, it does work. Yeah, 725. No, that does work. That does work. That does work. I was right before. I was right before. That makes me feel better. That makes me feel better that I was right before. Okay. It's just hard for me to see in my head. Okay. So I wonder now, yeah, I'm beginning to think the way this is going to get solved is this is going to be forced to come down, and that's going to force a lot of stuff here. It's going to force 9 here, 8 here, 7, 2, 5, and it forces everything. But it's not forced yet. I could still do 1, 3, 8 or 1, 2, 6 here. Have that go over. So, is it this? No, these can be quite big. And I mean, this is totally unrestricted. Is it this? Does this have to come over for some reason? I'm just playing with stuff because I don't know. I don't know what to do next. This is messing with my head a little bit. I haven't thought about this arrow actually because it seemed. No, I did, and I said that has to be at least 5, which was like nothing. Can you do better with this because of this cell? Did I not think about that? I thought I did. Maybe I have to think about what high digits have to be here. Well, is there any way this isn't 8 or 9? Let's start there. If this is 7, let's say I did 3 shaded cells, which is the most I could have. If I had 3 shaded cells, which is the most I could have a 1 unshaded, 2, 3, 5, say. I mean, that's as low as 6. That is not restricted at all. So what am I missing? There's something here that I just don't see. So this connects either here or here. Is there some reason that connecting here or here is bad? If there is, I don't see it. Definitely doesn't go down here and doesn't go down to here. So it's one of these two. So this either goes now or later. I guess either way that this doesn't bend out because this connects here. So that's green, which is like totally useless. But I don't think this has to go over now. Yeah, I mean, even I was thinking, does this need? Yeah, I'm conflating some ideas in my head. I just don't know. I don't know what to do next. Is this something? Is there just some? Am I missing Sudoku? I'm probably missing Sudoku. Let's go back for a second. This is 4 or 5 so that's a little something. Because this is 1 from 4 or 5. It's either 4 6 or 5 7. So actually, these are the same parity. Oh, there it is. Wow. That's really nice. I should have looked there. If this is 6, this is 4, but this is also 2 4, which just immediately breaks. So that's 7. That's 5. Oh yeah, that's gonna do everything. 4 6, we said that's 5 goes with 3. This is a 1 2 pair now. Oh my goodness, this is great. That's now 8. How? I should have. I'm sorry to everyone watching, yelling at me. 1 2 3 There's no 5 here, so that's a 3-4 pair. That's a 2. It just does everything. That's a 6. And I probably know exactly what these are. They're 7, 5 is 12, 4. So that's 3. These are now 8 with what? 2, 6. Wow. Wow, 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 wow. And now I bet I get all kinds of new insights that I didn't have before. Weirdly, so I have 1, 2 pair here. This is at least 3, 4. This can't be 7 anymore. Oh, 3, 4, 1. That's minimized now. That's 9, 3, 4, 1. Wow. This is maximized. This is minimized. And again, I thought about this in my head as doubled. So 1 doubled. The only way this could have been a 2 is it was 2 with 1, 4, which was no longer possible. What did I have marked there? Yeah, because I have this 1, 2 pair now. Before this could have been a 3. That was it. Yeah, okay. I feel good about that. That makes this 6, 4. So now the smallest this could be is 2, 5, 6. And even that doesn't work because it's not even. 2, 5, 7 is 14. So this is at least half of 14, which is 7. And now we can do this because I think this had to be 7, 5, 2 in our example where this was 3. So let's see, now that we've done all those intermediate steps, is there an easier way? Well, let's put those in first. 2, 1. Okay, so let's think about this now. If this is, so let's say I have only 2 cells halved on this loop. That leaves 1, 2 unhalved, surely. And then at best 5, 6 halved. But 1, 2, 5, 6, that's too big. 3 and 11 halved is 8.5. Oh no. Well, it is too big, but I can only make it a little bit bigger by 5, 7. Yeah, it just doesn't work. But again, it's so weird with the odds. So let me just try to show you. Suppose we had this. Best case scenario, I put the lowest digits unhalved or doubled, if you want to think about it that way. And what do I put here? They've got to be the same parity, right? And the digits I have left to play with are 5, 6, 8, 9. So if I put a 5 in here, it's all the way to 9. Or I do 6 and 8. Either way, it's 14, right? So let's do 6, 8 because that leaves me at least a 9 to work with. That's 14 is 7 halved, which is just too big. It doesn't work. It just doesn't work. That's because of the parity. So I need 3 here halved. So how do I get 3 cells halved? It can't be those 3 because that would break these loops. So that's looped, which means these are not looped because loop can't touch itself, which means those 2 are looped by the halving principle, which means that's not looped because this isn't going to bend towards itself. It's going to bend this way. I don't know which way it goes here, but we'll get there. Now this is super restricted. This is either, it's not 6. I was going to say 6 or 8, but it's not 6. So that's 8, which means those sum to 4, and this is 1, 3. The reason, so first of all, it has to be even because it's halved and it sums to an integer. So, and it can't be 4 because these have to sum to 2, which you can't do with different digits. So that's the way it goes because 6 is taken. I get a 3 kind of X-wing here. Which might be useful at some point. I don't know. I don't see it yet, though. These 3 digits are going to be 2, 7, 4. Is that helpful? I don't see it. Okay. Oh, hold on. If this is 7, if this is 7, this is 257, which has 2 7s in it. So that doesn't work. That's an 8, which means this sums to 16. There's no way to do that without a 2. So the least I could make it then is 5, 6, 7. So the other 2 are 14. It can't be 6, 8, so it's 5, 9. Is that really right? 2, 5, 9? Just like that? I think it is. At least 6, 7 here. I think that's right. And then these two, 5, 7, and what? 8. Oh, 8. Where does it go in the column? Here. I got a 5. That's a 5 because 7's over here. Wow. A lot of Sudoku here I can do if I just think about it. What has to go here is 6 and 7. I think that's helpful. And same thing here, I can do 1 and 2, but I don't think that's helpful either. Okay, so now I think this has more slack now. Yeah. I think this has a lot of slack. Oh, does this have to be 9? Because it can't be 8 now. So this can't be 7 either. There's no way it's 6, right? If it's 6, we could put a 1 here. 2, 5, 8, it would have to be at least. That's 15. That's way too big. So this is a 9. We got a 9 down here. This could all be halved, so I could put a 9 here. I get a 9 over here. Well, one of these, I probably can figure this out. My digits here are 1. Can this be a 2? If that's a 2, these sum to what? These sum to 16. I don't. Is that right? No, so these sum to 14. If this is a 2, these sum to 14. I've got a 1 available. What do I have? 1, 5, 6, 8. 1, 5, 6 is 12. 1, 5, 8. Oh, it still works. I can't believe that works. 2, 1, 5, 8 works. Yeah, no, this is really slack. But this has to be 1 or 2. There's no way it's 5, right? If it's 5, yeah, that would have been 8, which just doesn't work. So, oh, but actually only barely just doesn't work. If this is 5, this has to be 1, 2, 5, because 3, 4 are taken. I mean, even 5 just barely doesn't work. So that's a 1 or 2. What can I say about this? Basically nothing. Yeah, I know literally nothing about that from the arrow. Okay. I know these are the same parity, actually. Oh, actually, that's interesting. So if these are even, it's 4, 6, because 2 and 8 are in the column. So if these are both even, it's 4, 6 with a 5. So either that's a 5, it's odd, or, oh no, that's not the way it works. Or if these are odds, it can't be 1, 9. It could be 3, 5, 4, 3, 7, 5 again. Say 1 and 9 are taken. So they'd be from 3, 5, 7, which only has 3 choices. 3, 5 would make 4. 3, 7 would make 5. So that's somewhat restricted, actually. I guess I got rid of 3 and 7 from just Sudoku. Okay. Wait, 4, 3, 5. 5 has 2 choices. Yeah, no, those all work. This could do this. I mean, there's just lots of wiggle room here still. That's not loop. So this has to keep going out. But this could still do this. It could go straight over. It could do this. But this is not loop, I think. Yeah. This is going to connect here somewhere. That's not loop. Oops. That's not loop. So maybe that is starting to restrict this. Because actually, yeah, this is pretty small. This is no more than 6. This is no more than 6, which means these are all the same. Yeah, this, no, that's not what that means. It means this is not halved. Because if this were halved, the most this could be is 6 by Sudoku. So if this is halved, suppose this is not doubled. I could do 3, 1, 2. That's the best I could do. That's 6 already. But this has to be 3 at least double. I mean, this is at most 6. This is at least 3. 3 doubled is 6. We're already there. And then you got to add more here. So this cannot be halved. So we get this. And since the smallest this can be is 6, I mean, oh no, these halving is good. Halving works for me. So I could do halving, actually. And if these are both halved, I could do, these couldn't be both, so this could be 1, 3. But I'd probably be better off to do 1, 5, 3, because this is at least 3. So this is 5 or 6, because just by Sudoku, this is at least 3. So does that mean I have, no, because I think 3, 1, 2, 6 works. I was thinking, does this have to go around? That would be a nice way to finish. I get 2, 3, 4. Oh, no. This loop has to go to here. This loop has to go to here. Wow, that's really neat. I wouldn't have seen that if I hadn't been thinking about this. This loop has to go in here because 9 is not in this cell. There's no 1 on this, and there's no 9 here. So I need halving somewhere here. And as soon as I put halving somewhere here, this is going to connect to this without going down here. None of this can be loop. Yes, because if this goes down at all, then it goes over and straight up, and that's all it can do. And that leaves this entirely unlooped. So these are all unlooped, which means this is 6, this is 3, this is not 1. So that's the 2, that's 1. Wow, that's loop. Wow, so 8 is in here. Now I'm wondering if this has to be 2. What happens if this is 1? I mean, I should know. I have 4 digits here. I know what they are. I know which one should be doubled. So to sum to 18, these 4 digits are 1, 2, 5, 8. 1, 2, 5, 8 sums to 17. I want to double something to get to 18, so that's the 1. 1, 3, 1. I have 2 or 5 here. This can no longer be 4, because I'll put a 3, 5 here. If this is 5, we would get 4, 6. That's still good. If we get 6, this has sum to 12. It would be 5, 7. That's also good. But either way, I get a 5 here. So that's a 2. This is now a 5, 8 pair. 3. 5, 4, 6, 7. That's one possibility. Oh, 6 is over here. What happens if 5, 4, 6? Yeah, so 5 and 6 are here either way. If this is 6, 5, 7, 4. So I have 2 choices here. Wait. No, 4, 7. Hold on. Let me just try this again. If this is 5, this has sum to 10. 1, 2, 3 are taken. That's 4, 6. That'll be 4, 5, 6, 7. So if this is 5, this is 7. If this is 6, you sum to 12. 3, 9 is taken. 4 is taken. This will be 5, 7. So it'll be 5, 6, 7, 4. Great. So there, 4, 5, and 6 are here. So what has to go here? 9 has to go here with 5, with 4, with this digit, whatever that is. And then the other one will go here with 2. So 2 goes here. My Sudoku. That means it goes here. Yeah, let's just do some Sudoku. I might be able to. Although that's probably all I have. As soon as I think to do Sudoku, nothing becomes available. This is probably going to be 8, right? Maybe. Is this restricted at all? Because this is... No, this could be... This could still do this. I was thinking this had to be green. No, but even if it's green, that makes this less restricted. Okay. I'm in my head. Okay, 1 has to go here. Oh, yeah, Sudoku. Yeah, there it is. 4, 3. So now I know these digits are 4, which I don't know anything about. 6, 7. I know a little bit about 6. And then these are 1, 2, 1, 2, 3. Oh, that's nice. 4, 5, 6, 7. So it's pretty big. Could this go over like this? Well, that'll force the 1 here, because it'll either be the, well, yeah, That's a lot of ifs. I'm not even gonna say it again. Okay, ones. So this is 9 with 4 or 7. This is also, oh, I get a 4-7 pair here. There we go. That's something. That's 5. Okay, 5. There we go. I do get some Sudoku. It's just Sudoku. Just do the Sudoku. Just do the Sudoku. It's pretty easy. 8s are over here. 1, 2, 3, 4, 5, 6, 7, 9. Is this really possibly 9? I could do this. This could be 8. This could sum to 16, 9. 2 things sum to 7. That would be 3, 4. But that does work. One, 3, 4, 5, 6, 7. That's a lot of choices. This is either 4, 6 or 5, 7. There's got to be something. There's got to be something. 4, 6, 7, 8, 9. Well, 8's over here. With no, there's too many. There's two. Three has to go here. Oh, I'm so sorry. That probably sounded awful in the audio. I can try to take that out if it's too bad. 4, 6, 7, 8, 9. How does this end? Is there any way this does that? If this does that, it's just a normal arrow. Can this just be a normal arrow? Probably. Why not? This has to be 6, 7, or 8. This has to be 6, 7, or 8. But those all are great. It doesn't even do much to restrict this. I don't know. What are we meant to see? 1, 2, 3, 5. This 1, 3, 6, 7, 4, 5. I don't know. What? This is pretty big. This is at least 4. Oh, there we go. This is going to do. This is at least 4. This is at least 5. This is at least 3. This is at least 12. This is at least 6. Is that anything? 4, 5, 3. I mean, that's very tight. 6, 7. I mean, that does a lot of things, but it's a lot of look ahead. And I might be right. Maybe I could do it in the puzzle. I haven't. In my head, I haven't gotten to a contradiction yet. Because if I don't know. Okay, let's think about this. Is there any way this is right? For some reason, this feels like this can't be right, but I don't see any problem. This is at least... No, yeah, because, I mean... If this is a good arrow, this is at most 4. This becomes 1, 3, 4. This becomes at least 6. Oh no, this can't be 9. This is at most 3. So, if this is a real arrow, we get a 1, 3 pair here. But, alas, it is fine. Is there some Sudoku I'm not seeing? Probably, but I can't find it. Fives? Something on fives? No. Well, it's not 5. Oh, that's not 5. Oh, that's not 5. So there's something with Sudoku, but okay. So this, okay. Now if this is a real arrow, is at least 7. So we 7, 6, 1, 8, 7, 1, or 8, 6, 8, 6, 2 doesn't work. If this is a real arrow, that's 1. This is 6 or 7. That's 7 or 8. Either way, 7's here, so that's 4. That's too much. What? I don't know. I don't know. Now, can this not be 6 now? If this is 6, we get a 7 here. We get a 4 here. This is 6. We get 7 here and here. Maybe this has to do this. What happens if this goes up? No, I mean, this could definitely go all the way up. Almost surely. I mean, we just did 3, 5, 4, 6 works. That's not 2. Maybe I have to do things like that and just whittle things down with Sudoku. 2's in a corner up here. So 8 and 2 in this row. I only have 1 free digit to play with. That's what it is. This can't be 1, 2, or 3. So where's the complement to this 1 or 3? It's in this row with 2 and 8. Wow. So this can't be 6 or 7. Wow. Is that really what I'm? So maybe I should. What can this digit possibly be? 1, 2, 3. It's 4, 6, 7. So I get a 4, 6, 7 triple here. That is what I meant to see. So that gets rid of 6. That's an 8. That's a 6. And now I bet this could probably still be 16. Well, actually not. Maybe now this has to go up. What if it doesn't go up? I could have 3, 4. If this doesn't go up, this has to be even, which means it's 4. Which means these sum to 6, and I have 1 and 4 taken. That doesn't work. This has to go up. That's not loop. And then what? And then so these are all from. So this is a 2. These are from 1, 2, 3 now, and then this is 1 and 3. So that's 2. That's 1 or 3. 3. No, any of these could be 3 still. Okay. I was hoping to get a 1, 3 pair here too, which looks like a deadly pattern, but this arrow can resolve it. 5, 6, 7, 9. So can I do it again? Can this not go over still? So if this, but now I get a lot more wiggle room because I get 2 cells that could both be odd. There's nothing wrong with this. Oh, there might be something wrong with this because this has to be quite big. It could be 4, I guess. 4, 7, 1 works. I was thinking this had to be bigger, but it doesn't. Actually, 4, 7, 1 doesn't work. 4, 6, 2 does, though. It's probably Sudoku. I can hope. I can hope it's Sudoku. All right, let's do some Sudoku. 2s are done. Oh, it is Sudoku. 2, 8. And then what does that 8 give me? I probably can place an 8. Yeah, oh my goodness. Now this definitely can't be doubled. So that is green. That is gray. This can't be a 1 anymore. It's got to be even, actually, which means it's 4 or 6, which goes... No, the only way these have to be minimized. 4, 6 is the way that gets to 8. Yeah, there we go. That's 5 now. So that's a 4. That's 6, 4, 7. 4. This is now a 9. 7 pair. There we go. That was, I think that was the last bit. These sum to 16. Let's just do this by Sudoku 2 ways. I need, what do I need here? 5. Still know where that goes. 4 does this. 4, 5, I still can't disambiguate. Yeah, I know these 2 digits. These should be 7, 9. Which I still don't know the order of. Okay, but I'm starting to get a picture here. 4, 6, 7, 9. Okay. Yeah, so I think these are all just... Okay, let's think about this arrow. These sum to 16. If that's a 9, these sum to 7. They have to be 3, 4. So if it's 9, it's 3, 4. If it's 7, they sum to 9. 1 8's taken, 2 7's taken, 3 6 is taken. It's gotta be 4 5, but that's taken up here by one of those digits. So actually that's the only way it works. It's 7, 3, 4, 5, 3 goes away to here. That's 3, 1. That's 5. That's 9. We are done with this puzzle. Which is a shame because it's great, but it's nice because I took over an hour. So oops, I did that wrong. That's 9. That's 4. And these are my last digits. Hopefully we're done with this puzzle. Oh no. Okay. This is wrong. I did something wrong here. Hold on. Oh, this had to be 9. Okay. This had to be 9, 3, 4. The 7 didn't work. This had to be 9, 3, 4. Everything else I think was fine. This was a different digit before, probably. What was it? 2? Yes. 3, 1. Gotta do this one first. What am I missing? 6, 7, 9. No, I hope we're done. What? Oh no. So maybe it's. Let's go back here. Okay, let's go back here. No, you know what? We're gonna go forward. I'm gonna see why it's wrong. I'm gonna look through and look for. So 8 is 6 plus 2. 8 is 16 basically. That's 16. 5 is 10. 9 is 1, 5. Oh, this is wrong. Oh my goodness. That should be 6. No. Oh, what did I do? This should be 2, 1. I did the math. I did this math wrong. 1, 2, 5, 8. Oh my goodness, that's bad. 16. It's 16. I don't know how I got to 17. 16. The 2 needs to be doubled. Oh no. Oh no. Hopefully everything else will more or less go the same. Sorry, everyone. I especially feel bad for the people that are kind of jumping in and out looking for like when they get stuck. That had to be a 2. Ugh. Well, hopefully if they did that, they saw my math error and did it correctly. That's 1 or 5. Oh, that's totally different actually. No, that's totally different. But I had that before actually, from this 3. So this now becomes 5, 8. Okay, so it's not We can maybe salvage this. These are all 4, 5, 6, 7. If this is 4, that can not only be 4. That still holds. This is still 4 or 7. So if this is 5, it's 4, 6, that's 7. If it's 6, it's 5, 7, that's 4. The digit I need here is 2, which goes here. Those aren't 2. That is, yeah, no hard feelings if you are bouncing. That's 4. I am going to try to, there we go, 5. So a lot of this is actually the same. It's the same basic ideas. This is a 1, 2, 3 still. That's 1 instead of 2. Okay. Is this still a 4, 6, 7 triple? Yeah, that's still a 4, 6, 7 triple. So these are from 1, 2, 3, and 8. This can't be 3. There's no way that's 3. This cannot sum to 6, even if it's all shaded. So that is an 8. These are from 1, 2, 3, so that's a 2. Yeah, it's all the same basic ideas. And now we can't do this, right? Because if this doesn't go up, that has to be even. Even if it's 4, that's 2. Even if the digit is 4, that adds 2. These are summed to 6, but 1 and 2 are taken. So this has to go up. That's not loop. 2, 2. That's the 2. That's the 6. That's the 8. And 8 here. If this is 8, this has got to be not loop, which means this would be even. But I think it worked. 4, 6, 8 works. Okay, so that's possible. All right, let's just check my Sudokus. 2s are done. 1s are done. 3s are here and here. 4s, I probably have a lot to do on 4s. 5s. Oh, check that out. Digits. And that gives, it doesn't mean it here. Okay, and now this can't loop in, because if it loops in, this is a 16, it's got to be a 7, 9 pair, 9's taken. So that is off loop, that is loop. I can't remember if that's exactly how it went before, but it seems pretty familiar. 8, this has to be even now, so it can't be 3, that's my 3. This is 4 or 6. If it's 6, this is 5, which is still possible. If it's 4, it's 6. So one of these is 6. Oh, it can't be 5. 5 is taken. That's 6, 4, 7, 8. No, it's there. I'm missing 5, 7, 9. So 5, 5. There we go. 7, 9. 5 does this. 3 does this. This sums to 16, this sums to 13. This is 4 or 6, but I can't be 6. And then now, because this is 5, now this is 4, 6. That's 7. 7 does this. 4 does that in the row. This is now 7, 9. This makes that a 9, and this is 6, 7. Oh, there we go. Did it. Wow. If you stuck with that, I don't know why, but I appreciate it. So thanks for the puzzle, yttrio, and thank you for suggesting it. And yttrio, I got a comment on the doubling loop video. I suggested it. It's a really great puzzle. I just can't do Sudoku or basic arithmetic, I guess. So thanks. I will see you all later. Bye.